A singleton in Java is a design pattern that ensures only one instance of class is created and provides a global access point to that instance. So think of it like a CEO object. You should only ever have one CEO per company. And like you use singleton when you only need one object like a logger class or a database connection pool or a configuration manager. So imagine having a multiple connections trying to manage a single printer. It's a chaos, right? So that's why we have a singleton, which prevents multiple instance of a class, then provides a global accessible object, maintains a single thread configuration or cache, then it controls access as well, like it can restrict instantiation and control resource usage. So here are some of the real world use cases like logger class, configuration manager, database connection pool, web service client, and game engine. So here are the like real world use cases of singleton. Let's say a simple example for singleton implementation. It's a lazy initialization. So here is a singleton class. What we are doing here is like we have created a private constructor, so only one can instantiate it from outside. So it's a private. Then again static variable which holds the single instance. Then public get instance method returns the same instance every time. First it checks whether instance is created or not. If not, it will send. If it is not created, then it will create one. Otherwise, it will send the existing one. And if you see when two class are created, but reference are same. And thread save singleton. So it's useful when multiple thread try to access get instance simultaneously. So most efficient thread save singleton used in real time, but in the singleton pattern, so we want to create only one instance, right? So if multiple thread try to access get instance, so they might create multiple instance. So to avoid that, we have a synchronize, like I have used synchronize here, or we can use synchronized option. And but synchronizing the entire method slows down the performance. So for that we have a double checked locking system. But here you can see if we synchronize it like only one, like here you can have the thread safe operation. For high performance, as I mentioned, like to have the better performance, we have a double check locking. So checking once if the instance is null without locking, then if it is null, then we synchronize it. Like inside the synchronized block, we check again and create the instance. So you can see first check, we are checking whether instance is created or not, then we are synchronizing it. So in above case, we are synchronizing whole method like before checking the instance. But first we will check the instance here in case of double check singleton. Then you can see first check, then again after synchronize we are checking second time. So if it is already created, then we are sending the instance object. Then we can also use static block. So another thing here is we are using volatile keyword to ensure that changes are visible across the thread. So then comes the singleton with static block initialization. So it allows exception handling during initialization. So here it's a static means instance creation happening within the static block. Let's see some real world use cases. The first one will be logger. So the same approach we are following, static variable, a private constructor, and then public instance. So we can have a single instance and use globally. So in case of logger class, like you don't want a multiple logger instance writing to different logs. So a single instance ensure consistent logging. So you can use like a logger get instance and use the option. Then we have a database connection pool which manages a shared pool of connections. You need only one manager for all threads to avoid resource leakage. I can see one manager to get instance and get the connection. Then we have a configuration manager like app wide setting. Example from config file, you should be read once and reused everywhere. Then cache manager. So a centralized in-memory cache like map or LRU. So used across the app to avoid reloading expensive data repeatedly. So real world, you can see one shared notepad storing frequently used data. Then we have thread pool executor to ensure a consistent resource allocation and to avoid many threads. Apps typically use a single thread executor. So we can have a fixed thread pool, which we have seen in previous videos. So then we have our system properties, like again Java's system.get properties or runtime dot get runtime returns a singleton instance. So then we have a window manager to control screen or window behavior. So only one window manager object should exist. So you can use window manager to get a single object. Then payment gateway manager, so which ensures consistent payment session, API keys or encryption keys throughout the transaction lifecycle. Then we have event bus again, which used to allow decoupled components to communicate through a central message hub. And at last, like we have a game engine controller in gaming, like a central class that handles game state, scoring, timing, and all. And there is a drawback of singleton as well, like we can can behave like a global variable, not good for testing and difficult to replace in unit test, and violates single responsibility principle by managing its own instance. So the best practices are use enum singleton, which Java recommends, and make it thread safe, make it lazy loaded only if needed, and avoid using a singleton where dependency injection is better, like Spring Beans. So this is all about singleton in Java. Thanks for watching.